stuff from Algebra 1, and so some of this you might not remember, and so it's one of those things you probably want to take notes and pay attention. Okay, but we're going to talk about representing functions, and we're just going to kind of pick a few sections in the 0 chapter to use. The first one we're going to talk about is what is known as the domain. Okay, the domain, and this is just taken from your book. So it says, recall that a relation is a set of ordered pairs. So basically, I have a bunch of ordered pairs. The domain of a relation is the set of all first coordinates. So the domain is all of the x's. The range is the set of all second coordinates, the y coordinates, from the ordered pair. So the domain is the x's. The range is the y's. So it says state the domain and the range of the relation. So we've got a little bit of terminology here as to how we're going to go ahead and write this. So we've got the domain. So I'm going to symbolize domain with the D. And then what I'm going to do is I'm going to put those, oops, that was a bad one, we'll try it again. I'm going to put a set of squiggles, which basically means the set. And now I'm going to put what the domain is. So let's look up here. What did it say the domain was?
Set of all first coordinates.
The set of all first coordinates are the x's. So here's the first coordinate. So that's in the domain. What would another one be? 0. What's the other one? 1 and 2. That is your domain. Okay, not too bad. Now we got to find the range. The range is the set of what coordinates? The y's. So in this case, what is that going to be? 3, -7, -5, 4. Okay. That's the range. Oops, let's go back. There we go. Now notice what it says. A relation can also be graphed on a coordinate plane. A coordinate plane is formed by the intersection of the horizontal axis and the vertical axis. Remember, the horizontal is x, vertical is y. The axes meet at the origin and they divide the plane into 4 quadrants. Remember how we number? And we always use Roman numerals. 1, 2, 3, 4. Any ordered pair in the coordinate plane can be written in the form x, y. So now let's look at the next coordinate. Name the quadrant in which t, the point t, -8, 5 is located. So, if I was going to plot the point -8, 5, where would I go from the origin here? -8, 5. Where would I go from the origin? What would I do?
Over.
I go, yep, left 8, and then what?
Up 5.
Up 5. What quadrant is this in?
2.
There you go, there's your answer. 2. Okay. Remember, you always graph your x's first, that's horizontal. Y's is vertical. Okay, oops, oh, God, it's skipping it. A relation can also be represented by a table or a mapping. A mapping illustrates how each element of the domain is paired with an element in the range. So these are all examples of relations. You can write them as ordered pairs, right here. You can write them in a table, right here. You can write them as a graph, right here. Or you can write them as a mapping. Now notice how the mapping works. 1 and 2 are paired together. 1, 2 is the ordered pair. -2 and 3 are paired together. -2, 3 is the ordered pair. So these are my ordered pairs here. Okay, and that's how a mapping works. Notice it's got the domain all in a circle, or in an oval. It's got the range all in an oval, and then it uses arrows. So now we're going to define what a function is. A function is a relation in which each element of the domain is paired with exactly one element of the range. Okay. Each element of the domain is paired with exactly one element of the range. Alrighty, so it says state the domain and range of each relation, then determine whether each relation is a function. So first of all, what's the domain of this first one? Okay. Let's go ahead and do the range. What's the range going to be? Okay, so now we need to determine, is this a function? So basically what that means is that each x, there's 10, 6, 7, negative 8, is that paired with exactly one y? Yeah, so that is a function, yes. Let's look at this one. What's the domain here? 1, 2, 3. Good, you guys caught that the domain here is going to be this, because that's the set of x's. So in a mapping, or in a table, it's a little different. Okay, what about the range? What's the range going to be here? 3, 4, 7. Do you think I need to write the 4 again? No, you don't need to. You could, but you don't need to. I would just leave it alone. So now, is that going to be a function? Why? 1 is paired with both 3 and 4. Okay. So, because 1 has 2 partners here, can't happen. Can only be paired with exactly one element of the range. Okay, so let's look at the next one. Same thing. What's the domain here? Negative 3, 0, 1, 5. What's the range? Negative 4, negative 2, 0, 2. Okay. Is that a function, yes or no? Why? Okay. Does negative 3 go to exactly one element of the range? Yep. Does 0 go to exactly 1? No. So it's not. Because 0 is going to both negative 2 and 0. Now, would 5 be okay since it goes to 0? Yeah, because it's exactly one element. Okay, so, all right, let's look at the next one. The domain is the x's. So this is what I would do if I were you. Let's start at this point right here. What's the x-coordinate there? The x-coordinate's negative 1. What's the x-coordinate here? What's the x-coordinate here? What's the x-coordinate here? 4. There's your domain. Okay? Now we're going to do the same thing with the range. We're looking up and down now. What's your y-coordinate here? Negative 1. What's your y-coordinate here? Negative 3. What's your y-coordinate here? 0 and 2. So that's how I would do the domain and range. First of all, I've got to get a 2 there. For that one. Now, each x, was that paired with exactly one y? That's a function. Questions? All right, what you need to do for me for tomorrow is just on page P5. You're going to look. I just need you to do 1 through 12 right there, real quick. It's not going to take you an incredible amount of time, and in fact, if you work right now, you probably could get done with the whole thing. Okay, so that is due tomorrow.